Hi everybody, welcome to Network Check Zone. In this video, we will configure route redistribution. So we know that route distribution allows routes from one routing protocol to be advertised in another routing protocol. And it is common in environments that support legacy equipment, proprietary protocols, or that have merged with other networks using different routing protocols. In this lab, we are going to choose two different routing protocols, which is OSPF and EIGRP. And the topology is very simple. I have just taken three routers connected via 10.1.1.0 network with /24 between router R1 and R2. And between R2 and R3, we got 50.1.1.0 with /24. Between this area that you see for router 1 to router 2 is going to be configured for OSPF area 0, which is the backbone area. And between the router 2 and router 3, we will configure EIGRP with AS number 100. So we will have two different routing protocols, and we will be using the concept of route redistribution so that we will allow the routes from OSPF to EIGRP, and from EIGRP, we will allow it to OSPF. And then we will try to ping from router 1 to reach router 3 and see if that works. So let's go ahead and configure the OSPF, since I have already pre-configured the IP address for these interfaces that you see in the diagram. So we will just configure OSPF. We are on router 1. On router 1, we will configure router OSPF process ID 1 and advertise those network which was directly connected to 10.1.1.0. It's /24 wildcard mask that will be 0.0.0.255. And area is area 0 because that's our backbone area. Here it has to be 10.1.1.0. Okay. And we will configure OSPF for router 2 and also EIGRP because we got 50 series on the EIGRP area. So R2 configure terminal, it's already there. So router OSPF, I'll take process ID is 1 and network is 10.1.1.0 wildcard mask. Area is again 0. Okay. And we have one more to the 20 series, I guess. Yeah, so it's the 50 series. So 50 series has to be configured for the EIGRP. Okay, the one that you see in the blue. So configure terminal, router, EIGRP 100, network. Network which you see here is 50.1.1.0. And if you give a question mark, it's asking for the wildcard mask. So I will still take /24, and wildcard mask is going to be 0.0.0.255, and no need of area here because we are working on EIGRP. I'll just press enter. And you can give no auto summary for EIGRP and version 2 if you would like to. If not, it's okay. This is on the router 2. Yeah. And this is router 2 is configured for OSPF and also for the EIGRP. Now we'll go to configure the router 3. So on the router 3, we need to just configure EIGRP. So router OSPF EIGRP, sorry, it's the router EIGRP 100, yeah. And network, and network we have for this router is again the same, 50.1.1.0 and wildcard mask for /24 and enter. So there you can see the neighbors are showing new adjacency, okay, and no auto summary. Okay, so that's about the EIGRP on this router 3. Now we will try to see if you can reach router 1 and router 3 from R2. So I'm on R2, the router that you see here. So ping 10.1.1.2, that is this IP address on here. Okay, so that's reachable. And we will try to reach this IP address 50.1.1.2, if that works, because they are directly connected. Okay, that's working as well. But if you want to try to ping from R1 to R3, let's see if that works or if it fails. So we are on R1, so ping the router which is present in the EIGRP. Okay, that's what we are trying to check. So 50.1.1.2, that's failing because if you see the routing table, you will not be able to see 50 network. Okay, so let's just wait. It's trying to show IP route. If you see in the routing table, you don't see the 50 series because these are different routing protocols. So though if you have two different routing protocols, in order for these routers to understand the routes in the other routing protocol, we need to allow the routes, and that can be done by using the route redistribution. So now we need to do a route redistribution, and we will choose this router. So let's just run a command here. Show IP OSPF. It's saying here area backbone 0. Okay, but you don't see the area border because this is EIGRP and not area 1. This router that you see R2 cannot be your area border router. Okay, it just says area ranges. Just is number of LSs. And yeah, since it's in area 0, it's saying area backbone 0. So it's in the backbone area itself. Okay, so now let's go to R2 and configure terminal. And we'll create some redistribution. And before that, I would also like to add some loopback IP address here on this router 3. That is this router 3. So we'll add this loopback IP address that you see. So let's add that. So configure terminal. Interface loopback 1 IP address 1.1.1.1 255.255.255.0. Okay, so here we have mentioned /8. We will take one is this is a classful IP address, then this is subnetted. So 10.1.1.1.1 we will take a default subnet mask for class A, okay, /8, and we will configure one more loopback, interface loopback 2, and this we will make it as /32, the entire IP address, so 192.1.1.1 /32. That means indicating the entire 255 in 4 octets. Okay, that's there. But you can still see in the routing protocol, in the show IP route you will not be able to see those yet, okay? Because we don't have the redistribution. Now we will go ahead and configure the router redistribution. I'll go to router 2. On router 2, we need to configure redistribution, but here we also need to configure on the router 3. We haven't added this network in our EIGRP. So let's add that. So we are on router 3 and go to router EIGRP 100. Okay, and I'll allow all the network, not just 1 or 2 loopback. I'll just say network 0.0.0. Okay. And it's asking for the wildcard bits. I'll just say 255.255.255. That is 0. Okay. And no watermark. If you say show run in router 3, this is what you see for your EIGRP. Okay. Now we'll go to router 2. We'll choose EIGRP first. So within EIGRP 100 ACE number, we will advertise the OSPF within. So redistribute OSPF, and process ID is 1 metric, because this is the metric of EIGRP. We know the metric of EIGRP is bandwidth, delay, reliability, load, and MTU. So metric, if you give a question mark, you can choose anything. So I'll just choose 10,000. If you give a question mark, it's asking for delay. So delay is going to be, I will say 20,000. And I'll choose reliability, the highest IP address. Okay. And it's asking for, if you give a question mark for the, after the reliability, I'll just choose 1. And you need to specify MTU. The MTU, I'll just take 500. Okay. Now we will go to OSPF. So within OSPF, we will advertise EIGRP. So router OSPF 1. Redistribute EIGRP. And the EIGRP ACE numbers. If you give a question mark, it's asking for ACE number, right? So give that 100 for the ACE number. And since I have taken 2 different kinds, one is I've taken a classful IP address and one is classless. So this 192 has to be 24, right? I've just taken 32. So I'll just choose subnets. So if I choose subnets, so that's going to allow all of them. So I'll just say WR. And now just look at the routing table. You have 1.0.0.0/8. Let's just see. And you also have 192, 1.1.1.1/32. Okay. So this is how we can perform the redistribution. Now you can try to ping this loopback IP address from router 1 and see the results. So ping 1.1.1.1, it's reachable. You can also try to ping 192.1.1.1. That's also reachable. If you just want to reach this 50.1.1.2, let's check 50.1.1.2. That's still working. Okay, so this is how you can configure route redistribution and you can allow the routes from one routing protocol to be advertised into another routing protocol. I hope that this video is informative to you all. Please don't forget to like and subscribe. Thank you for watching and see you in the next video.